All right, so good morning or afternoon, and thank you everyone for joining the webinar this morning. Mobile mapping, easy, simple, and effective scan to CAD. So my name is Ivona. I'm a senior solution architect in GeoSLAM, looking at different workflows with our GeoSLAM base scanners. And today I'm joined by Graner from PointCab. He's a senior software developer. And I'm glad to have Martin on the call, as he'll be able to do a live demo and show Draw to CAD workflow. Also to talk about a little bit what is new in Draw and answer all Draw-related questions that we'll get towards at the end of the session. So Martin, do you want to say a few words at the beginning?
So yeah, as Ivona already mentioned, my name is Martin Graner. I'm working for PointCab as a senior software developer and as a team lead for support. I joined PointCab in 2016 as a working student while I was simultaneously doing my master thesis there, not at PointCab, at the university direct. And when I finished with that and I had my master in geodesy, then I joined PointCab as a full-time worker in 2017, and I've been with the company ever since. So that's me.
Go through. So we are going to start with some key considerations about mobile SLAM-based systems. I will introduce GeoSLAM family and the processing platform Connect. Martin's going to do a live demo, then taking GeoSLAM data through Connect into Draw to AutoCAD. And I pre-recorded a workflow that's going to show Draw to Revit workflow for building modeling. And we also have several great case studies that I'm going to share where they show the full workflow from data capture into CAD or BIM processing utilizing tools from GeoSLAM Draw. So if you're new to mobile mapping or consider using mobile system for certain projects, or if you're thinking whether to use terrestrial-based scanner or mobile systems, here are some key considerations or key points to think about. So sort of moving from left to right in a zigzag manner, we've got a capture time. That's an obvious one, a real advantage for mobile systems. But you should also consider what it takes to process data in terms of the processing speed, the computer specifications, the licensing, and so on. Accuracy, that's a frequent question, and it's highlighted here as not every SLAM-based system provides the same accuracy or works in different types of environments like outdoors as well as indoors. When it comes to cost of the system, that's important to take into account any associated costs. That could be software subscriptions, cloud storage, and others, not just the upfront investment. Then when it comes to workflow in your organization, the new technology should really complement the way you work and not force you into any proprietary formats or software packages that would not be right for you. Data storage and security, increasingly important questions nowadays. You should make sure that you own the data at the end of the capture. And the SLAM algorithm, or the simultaneous localization and mapping. This is the key component for those systems to work in indoors environments or any GNSS denied environment. And SLAM algorithm should allow you to provide always accurate data from the scan. And again, this is not the same across all the products available in the market. And of course, the hardware consideration, which system is the best for your work? Do you need to scan indoors or scan outdoors as well? Do you need to capture data from the vehicle or scan in the tunnels? You should consider factors such as the range of the scanner and the battery life as well. So I'm going to talk through those considerations a little bit more. Fast data capture can be a real advantage when there's a limited access to the building, or when the building is somebody's home, when it's a hospital, airport, building under construction. Being able to scan such environment fast will cause the minimal disturbance And fast capture means that you can capture more scans per day, which can increase the profit. Processing, that's often as important as capture time for a quick turnaround of the data. In GeoSLAM, we focus on automation of data processing, especially in our new Connect platform. And I'm going to talk about Connect a little bit more as we get to the live demos. However, processing time is going to vary depending on the system use and the data size. For large projects that are scanned, for instance, with the terrestrial scanners, the processing time can exceed days when you really just need to start working with the information that you captured. Accuracy. So with our SLAM-based systems, we are able to achieve a local accuracy within the data of 6 millimeters, global accuracy between 1 to 3 centimeters, but often if the data needs to be georeferenced, we also have several ways of doing that where we can, for instance, georeference the data without modifying the point cloud accuracy with the use of network of control points. That's called rigid transformation. Or we can also adjust the point cloud to fit the control points, which would be a non-rigid transformation. When it comes to global levels of accuracy, we also have different methods of georeferencing data. For instance, when SEB Horizon can be clipped on a backpack and used with a GNSS receiver, where the data is then processed and georeferenced in the post-processing stage. And when it comes to data workflows, we try to provide export formats that can be taken to your choice of software platform for further processing, whether that's a CAD package or other software. Total life cost. Every GeoSLAM scanner comes with software and care package. There are no additional software subscription costs or extra costs when it comes to cloud storage or data processing. Data is processed locally on your machine, and files are also generally small, around half a gig or less per 20 minutes of data capture. Scanning environment. Our systems can be easily switched from handheld mapping to backpack, car, or UAV capture, hence work also in different environments. So you can capture tunnels, caves, golf courses, anything that you can imagine, as long as there are features in that environment, as that's one of the key requirements for SLAM to work. So for the features outdoors, buildings, parked car, trees work quite well, and indoors, generally furniture works really well as well. Data storage and security. You are the owners of the data that you capture. And as the data is processed locally on your machine, that can be done with online and offline license. And you don't have to purchase cloud for storage or processing, where the security policies of that might often not meet the policies of your own organization. SLAM. So SLAM is within our company's name. We've worked with SLAM-based systems and perfected the algorithm over the past years to work for each of our systems and work in different environments as well. For the demonstrations that we'll run, we are going to use unedited data just as it comes from the scanner. As you would often see nice and polished data sets out there that were further filtered, modified, and edited, often the process that can be time-consuming and not really a part of your own workflow. And hardware, which hardware system would be the best for you? We've got a range of systems that come with different accessories that allow you to, for instance, drop the scanner into a manhole mounted on a cradle. There's an extension pole to map the ceilings or get a better access to vertical structures. We've got a backpack for hands-free collection, different camera options, so you can collect images as well as point cloud data, car mounts, and others. So with this, I'll introduce ZEP family. ZEP Go, Revo RT, and Horizon are the core products, where ZEP Go is the first step into handheld scanning. It's the most affordable one, and it's got a range of 30 meters. Similar like ZEP Revo RT, it's got the same range. RT stands for real time, so you can actually see the data as it's being captured, which is a great advantage in very complex buildings, but the data is also processed real time. Both systems capture 43,000 points per second, got 30-meter range, and are really great for indoor mapping. On the right-hand side, we have ZEP Horizon, which is the ultimate mobile mapping tool. The system is capable of capturing within 100-meter range. It captures over 300,000 points per second. And because of the range and the number of points, we've got additional options to capture the data on the car. You can mount it on the UAV. Now on the DJI M300, it can be mounted on a backpack with addition to 360 camera, which is great for street mapping, that's ZEP Discovery. We could mount the GPS receiver on the top for data georeferencing, that's called ZEP Locate. And all the other accessories like cradle, extension pole, and others are available for the whole ZEP family. Each of those systems is powered by our robust SLAM algorithm, GeoSLAM Beam, that allows it to work with a number of accessories and work in different environments. And when it comes to data processing, we've got a new platform, GeoSLAM Connect, that processes the data automatically for you. So when the data is collected, it's saved on the data logger, where you can download the data for Go or Horizon by a memory stick or from the ZEP Revo RT just over the Wi-Fi that you can connect to it via your computer. Data is in .geoslam format, and Connect's got a preset of workflows where you can specify what output you would like to get from the data, what filtering you'd like to use, spatial decimation, and others like change detection. So once you set your data into project for processing, it will run step by step through point cloud processing to get into the desired output that you specified, meaning that you don't have to wait for one process to finish and set up another. And I'm going to stop here as Martin's going to be able to show you the workflow a little bit more, especially taking the data which was captured by ZEP Revo RT. It's unfiltered, unedited, just as it comes from the scanner. So Martin's going to show the draw to CAD workflow. After that, we'll get a little bit back into data capture, show the workflow in Revit, and go through the case studies as well. So over to you, Martin.
Thanks, Ivona. Perhaps I should stop doing live demos and instead pre-record my stuff as well. Would be so much easier for me. But here, let me share my screen, this one. So now you should see that. You see GeoSLAM Connect. I can move around here, but we're not talking about GeoSLAM Connect now, but GeoSLAM Draw. You see I already created a PCP project here. If you want to create it for the first time, go to your results, LRSet, right-click, say open in GeoSLAM Draw, and your GeoSLAM Draw project will automatically be generated. I'll just double-click this one and it will open then. This is now going to be less of a demonstration of how the workflow in GeoSLAM Draw looks like, but more like a demonstration what results you can get out of there in 5 to 10 minutes. And I will just go quickly here through the things, generate some results, and then show them in any CAD software. In this case, I have only AutoCAD on my computer, so but it doesn't matter if you have SketchUp, Archicad, Allplan, Revit, whatever. So at the beginning, GeoSLAM Draw automatically generates these 3 standard views, which you can see here, and in these you normally work. And what we generate from the point cloud normally are these auto photos. So these are only images, no point cloud necessary. You don't need to transfer this. You can directly take the images. They are in an XREF of a DWG file, DXF, Collada file. So you can import them anywhere you like to, and don't need to worry if your CAD software can import a point cloud. So you can directly see here already, okay, here are different rooms, and you see here the cars. I mean, if we look at the point cloud, you see here the same stuff here, but the roof as well. So you can see here everything. And what you want to do normally is, generate, for example, a floor plan, a slice here. So we will just do that. Perhaps you want to have it at a certain height. Let's put it on 1.5 meters, and we make it a little bit smaller so you can slice it as you like to. And then you just press the process button, and everything gets processed. You can see it here in GeoSLAM Draw directly. And in your results folder, you see here a DWG file was already generated. Everything else you could just tick here as well, and then this would be generated while you press the play button, and everything is there. And as I've showed that, we can directly open that in AutoCAD or any CAD software. And there it is. And as you can see, I'm the perfect CAD user, not. So next, what you want to do normally is you want to get vector lines up there because it's just an image. You can here generate these lines yourself, for example, and then merge them, for example, say intersect lines, or you can try to find all the lines automatically. For example, here we see this room here is the smallest, so let's give it here. It's around 1.5 meters big. So our shortest line should be 1.5 meters. We want to find some more lines, process that. And since this is an automatic algorithm, we will then need to fix things here. For example, here you see, okay, it found this line, but here this line is missing. So then we would just here go there, start creating the lines which we need, and then fix everything up. And when we are finished, just export these as well. And they are available as a DWG file as well. We could just insert them here. They should be somewhere here. And you see the lines are directly here on my drawing. We have created them in GeoSLAM Draw. So everything directly available. We can insert sections as well. So if we want to have the height somewhere, let's generate one here. Let's get this on the wall directly. So process, if you like to, you can generate one through the building as well. We are looking now from the outside to the inside. So if I open that here, you can see directly the height of the room in the building as well. So let's measure here the height, for example. So here you can directly get your heights from there. And as these are created, we can add them in AutoCAD as well. Insert. So they are in the auto folder. Let's take this and, for example, the other one as well. And they are directly there where we have created them. They are completely at the right location. If I here select them, you can see where the lines are laying. So they are directly where we have created them. They are in the right coordinate system. I have one slice prepared for where I have already all vector lines done correctly. So let's go there. Here we have that. We should rename that. And I've exported these now. And what I wanted to show here is, again, perhaps we open this as well in another view, finished layout. The vector lines, yeah, let's add the vector lines as well, since we have them already. A 3D folder, this one, there they are. You see they have different colors because I set the color differently here as well. This one was it. So one blue, the other pinkish. The reason is that they are on different layers, so I can, for example, shut them off or turn them on again. Same for the sections and so on. I can just put them on different layers. Now, for example, you want to have a part of the point cloud indeed in the project, and let's take here the bathroom. So we can select just the bathroom, say this one, and depending which software you are using, you need a different point cloud format, right? So we are in AutoCAD, so we need the point cloud format in RCP. But if you are, for example, in Bentley, MicroStation, you would need POD. So POD, if you are in SEMA, you would need SPV, BricsCAD, LIS, LIZ, E57. But as I said, we are in RCP, so let's export RCP, but without the floor and the ceiling. This is exported, so you don't need to bring in the complete point cloud. You can bring in the only the part which you are interested in. Point cloud attach. This is the wrong folder. This is the right folder. And there is a point cloud. And you see the walls are directly aligned to the point cloud. And we can see everything is fitting nice and tidy. What could we perhaps bring in there as well if we want to? Let's assume we want to know the difference in height here at the parking lot. We want to know where the water is running to. So let's create some height points here. So we know where the highest and lowest points are. You see here we have a negative number. Here we have a higher number, but we want to just create where, this position here. If we like to, we can, center that directly on 0, for example. Change the height, so all our 3D points are in there. This seems to be a little bit higher. So, and now what we generate is a delta. Perhaps we want to export a PDF as well. So we can do that. And now we are creating a wrong image with wrong colors, I mean, where we can see the heights directly. So you see here now, okay, the red values are the highest points. The greenish cyan ones are the lowest. We can see the results directly in here. So you see here, okay, here's a 0 line, blue would be negative, red is positive in height, and we see that the water will go there directly to the building, what we normally don't want, I guess. But of course, we are able to, for example, put that into or I can show that in there as well, layout delta. We can put that in here as well. In addition, perhaps we want to get the surface in reality. So let's create a mesh here with the different heights. This is set to 10 centimeters, should be fine. And then we can here just add that in there as well. So another insert, there's the mesh, open, and here we have our mesh directly with the different heights. So let me turn off the section, and then you can see that the heights here are available. So if you want to have a surface model, this is there. And the last thing you normally want to produce directly from the start is some documentation, a PDF or anything, for example, to give it to your customers. So let's go here, let's do that. We have here our vectorizer. We want to have the floor, the room sizes. So I convert here to the areas. Let's delete this one area at the outer area. We don't want to see the vectorize anymore, or we rather want to have two distances here, these two. Now we hide these. Let's remove the scans as well, so we don't see these. Change that to arrows. Let's put this a little bit out there. This one as well. All right. And now we create a nice PDF. From that part, we take the area. You saw the scan positions. I will remove 2 of these because they are not interesting, because they are located here somewhere in the outside, 21 and 20. So if we don't want to see them, we can just deselect them here, 21, 22, or something like that. Change here whatever we need and export. How long have I been talking so far, Ivona? I have no idea. 10 minutes?
It's good workflow for me to see as well. Thank you. Around 10 minutes, yes.
So you see here the name, the team, some comments. If you write them down here, you would have your own logo if you want to put it in there. And there you see directly a scale from 1 to 200, depending on the size of your project. And you can see here the room sizing, so 7 square meters. As well as the distances, because I put them in there. And there are all the scan information, and then the panoramas there as well. So all the positions here, the bathroom, are available, which gives you great context to give to your customers so they know what they have captured there, as well as it's very valuable for you to have this information here, because then you can just open these. Let's go back to the bathroom perhaps. To understand what do I see here in my section. For example, if I put the section here, is this a wall or is this not a wall? So this is definitely helpful for your complete workflow if you have these panoramas. But yeah, these are some of the outputs you can generate in your point cloud to CAD workflow. You saw I used not many tools so far, and you saw it was just like, take the tool, generate it, press the play button, you have your results. There is not much fiddling around in the job editor where you have the options. So it's very easy for you to start with GeoSLAM Draw, get your results, which you like to see. And there is not much time needed to get used to it, to start working with it. I mean, Ivona, how long do you think would somebody need to play around with GeoSLAM Draw to be able to get their normal results, which they need for their workflow?
You can pretty much straight away pick the sections and the 3D tool that you've got there, maybe 2 days to be able to cover every tool that you've got. And I guess we'll talk about the packages as well, what's available where.
Yeah, right. But I mean, if you want to, if you look at orthophotos and vectorize, I think it would be 1 or 2 hours, and then you are good to go with that, in my opinion.
Yeah, with the sections, definitely that's pretty straight away.
Yeah. But I guess this would be it for my demonstration, what GeoSLAM Draw can do for you, what you can do with that. As I said, this is not a workflow. If you want to see an explanation video, what you can do, how every tool works, what the different options are in the job editor, then reach out to GeoSLAM. I guess they have recorded webinars as well and tutorials, and these are better suited than if I would just here explain every single option which is available here. All right, Ivona, do you want to go on?
Going to get back into presentation. Thank you for that. So maybe to back up a little bit, and also Martin showed how fast the data can be processed and how fast you can work with it and create the floor plans. But to get back into capture time, what it took to capture the data set, I've got a similar office style of a building that was captured both with a static and with a mobile system, just to compare the results. So first, to start with a static scan of this office block, it took about 125 scans to position the scanner into every room and doorway. We calculated around 2.5 minutes per every scan. That included the moving it from one position to another, which actually took hours on site just to capture the data. And it was gigabytes of data that needed to be processed at the end, merged, exported, and the processing took over 12 hours. So altogether, the capture and the processing time was more than 2 days with a terrestrial base scanner. When it comes to accuracy, the global accuracy was 1 centimeter and the local accuracy was from 2 to 3 millimeters. So my colleague scanned the same building with a Z3 VRT with a real-time system, following some basic scan practices, which is to have the same start and end point, looping around in each room, like walking around the table so you can see the trajectory in orange within the building, and things like transitioning slowly through the rooms, and for a good point density, maybe walking a little bit slower than the normal walking speed. So this overall capture with those considerations took him 30 minutes. And because the data or the system was real time, the data was processed instantly, but maybe took another 30 minutes to download the data and export it, do a quality check. So 1 hour total capture and processing time into the stage that you've seen what Martin shown, making it almost 18 times faster than doing the same project with a terrestrial scanner. And on the accuracy side, the global accuracy was from 1 to 3 centimeters, and local accuracy was 5 to 10 millimeters.
You didn't mention here, Ivona, let me just go back here.
Yep.
One thing which another great advantage the mobile mapping over the static scanning has. I mean, you know that if you are doing static scanning, you put your scanner on one position, it scans there, and then you go to the next position. So it's like taking a 360 panorama image at this position. For example, you see the dots everywhere there. The scanner was placed there. One disadvantage here is that you if you don't see certain things, like if you have a bathroom stalls multiple next to each other, you would need to place the scanner everywhere there so you're able to see everything in these images, so you have them in the point cloud. If you don't do that, you won't get data at that location, while with a GeoSLAM scanner you can just walk by and you have so much time saving just walking by these instead. And in addition to just walking by, you get the data at these locations because you don't need to wait there until you are finished, go to the next location until you have captured all the data, but you get it just by walking through it.
Yeah, it's also easier to capture any difficult places to access as you have it just handheld. You can tilt the system, get behind the furniture to make sure that you have everything covered.
Yeah.
So
the coverage rate is a lot higher. This is what I wanted to say.
Thank you. And I'm going to use the same data that Martin did. It's a similar office style building, and I just pre-recorded a video that will show how you can take the data, raw data, through Connect to draw into Revit. So I'm just going to start a video now. It's a little bit speeded up video where the data is already loaded in GeoSLAM Connect. Actually, to get to this stage of this capture and be able to see the data, it took just 2 minutes once the data was dragged and dropped into the software. So here I'm just using the bounding box to cut through the roof to see all the rooms that were captured. And in blue, you can see the trajectory as my colleague walked around the building. So this is how the data can be processed. There is a workflow associated to the project where you can just drag and drop your raw file, select the export format, select the decimation, the SLAM presets if you're capturing in a different environments like tunnels or capturing data, for instance, from the vehicle. And we've also got an option to filter the data, which will further reduce the noise and make the walls really nice and thin. That makes a huge difference, especially to horizon data. But for this data set, I didn't apply any filtering or decimation whatsoever. It took 18 minutes to capture. We collected some images as well, and the whole point cloud contained over 30 million points. So just right-click, open it in Draw. You've seen the generated views nicely aligned on Martin's side. So the first thing I did was just to align the views with the rotation of X and Y axis, which you can then apply it to the project, and it will generate the aligned views again. And the reason I chose this dataset is because it contains the Pano images captured by the Pano, a camera that actually mounts at the back of each system, and you can just take the image when you like during the capture. So you can pan through it in Draw, and on the left-hand side, you can see where in the point cloud you're looking at. So to start Revit, for instance, there's a 4CAD plugin button on the top, and with Revit's plugin and templates, you can start with a very simple toolbar on the top from starting creating the levels. So for that, I did just a section through the top view and use the bottom of the door frame as a floor one. And then you have the next tools moving from left to right, where you can generate the walls. And for that, I again did a layout through the building using a side view for that, where you can define the thickness of the layout, the image resolution for it. And I position it a little bit higher up to avoid the moving people and the furniture in this case. So I was looking for some clean section, which looks good enough. So for this, you can select the walls with the type that you like to create. And all it takes is 2 clicks per wall in Draw, and they will be modeled in Revit on the right-hand side. Another option is to bring this section into Revit as well. So the generated sections and layouts are in DXF, DWG format, so you can just drag and drop it in, and it can work quite nicely as a base layer for modeling as well. So I use that for the interior walls. Of course, the resulting accuracy will depend on the skills and level of detail of the person who was modeling this. It's a bit speeded up, but to get to this stage, it took me maybe around 10-15 minutes to finish this. There is also other option, for instance, to export RCP from Draw, which could be imported into Revit as well. So then I started to add some architectural elements like drawers and windows. And I got back into Revit's plugin for that, where using, for instance, the entrance door, I created the section through. So you can see the door and then select the Insert Door tool, which quite nicely shows you where to click and how many clicks to do for the door to appear in the model, in the wall. So I did a couple of windows and doors, and images were quite useful here just to see what type of window there was, in which side of the door the handle was placed, and detail like this, which is nice and easy to see on the image data. When it comes to accuracy the level of detail, generally we are within LOD 300 with the GeoSLAM data, and past that other technology can supplement the scans like terrestrial scanners. And level of accuracy scale is 30, that defines the local level of accuracy from 5 to 15 millimeters. Often during this process, accuracy can be sacrificed as well, depending on the person who is doing the modeling. So this means that even if you have more accurate scan, you might not have more accurate model at the end of the process. All right, I actually got just to this stage, just added a few more doors and windows, as then we've got a couple of case studies that actually show nicely the whole process from the beginning till the end. So the first case study, that's from Urban Studio that was appointed to scan a hospital in Caribbean, and that was a complex buildings with several floors and a lot of small individual rooms. So that was an enormous task to capture. I think originally they were thinking to use the total station, which was just quickly ruled out because of the scope of the project, and the only choice was to use a mobile system. They decided to use ZEP Horizon in order to capture both interior and exterior of the hospital. The capture time was 6 working days. They captured over 52 scans, and it took approximately about 20 minutes per scan, which is about the recommended capture length per one data collection. So the overall area captured was over 22 squared meters. And the scans were first merged in GeoSLAM software, and draw sections and layouts were then used further for Revit modeling. So I'm just going to play you a quick video of the end result. All right, the second case study, that's slightly different application. That was done for a property remodeling purpose in southeast France, where David Pierrot company was tasked to survey a villa which was placed on a steep hillside, and the goal of the project was to create a detailed topo map of the surrounding area and the building itself, and then architects would use the data for planning and conducting the construction work. Again, ZEB Horizon was choice of this project because it's got 100-meter range and speed of acquisition. Otherwise, using any tripod-based scanners, it would be quite difficult to work in this steep environment like this one. I'm just going to play the video of the capture. So they managed to do 4 captures, each was around 15 to 20 minutes long, and overall captured area was over 8,000 square meters. Point cloud was further classified for the ground classification in order to get a bit better understanding of the land before working with the data further. So here you can see the captured point cloud from Horizon with extracted ground. Where the individual profiles were vectorized and the whole capture was turned into a topographic one. I've got a last case study from Boston City Hall where I helped Aerial Genomics to acquire the scans. The project was now done a few years back, and this hall is quite fairly well-known brutalistic building from 1969, and it's surrounded by a huge plaza around it. It just doesn't get a lot of interest from local people, and people in general tend to have a bit of love and hate relationship with this place. So City of Boston contracted architectural company Sasaki for renovation, and Aerial Genomics were contracted to conduct the scans. For the capture, we used ZEB Horizon for the exterior scans. On the left-hand side, there is a picture of unfiltered Horizon data. It took 14 minutes to walk around the hall, and we collected 120 million points in that scan. And because of 100-meter range, basically we covered the entire plaza in one go. Horizon was further used in the hallway, as it had really high ceiling, so the 100-meter range was quite beneficial there. And then Aerial Genomics used ZEB Revo RT to capture every single room in the building as well. They had a limited time when they could access the building. They had the 4 nights actually when they could come in, and they managed to capture over 1 million square feet with Revo RT going into every single room. And just play the video of the capture as well. Where you can see the operation itself being quite easy. 2 buttons to turn the scanner on and just walk around the environment where moving people, vehicles do not matter, as long as you have static features like buildings or furniture or boiler rooms inside. So after data capture, data was first merged in GeoSLAM software, and then Draw was used for sections and layouts and RCP export to finish the BIM modeling of the building. And I'm just going to give a word back to Martin to maybe summarize what can be done in GeoSLAM Draw for the CAD workflow and mention the different packages available and new features within Draw as well.
Yes. So with GeoSLAM Draw, you are able to, as you can see here already, create these autophotos. You can do vectorization. The main idea of GeoSLAM Draw is practically that you bring in different point cloud formats, different point clouds. I mean, if you have a static scanner and you want to combine the data with GeoSLAM data, you're able to do that in Draw and process everything at the end to autophotos and reduce therefore the data sizes immensely because you don't work with the point cloud anymore but with images. And in addition, you see here at the bottom, for example, the Revit model with which you are able to get your results very easily into Revit because your point cloud doesn't go into Revit or only the parts you like to, but you're not working in a point cloud, you're working in GeoSLAM Draw. The point cloud is hidden away in GeoSLAM Draw, and therefore it's very easy to use, and you don't need to work around, move around in 3D practically. Packages. There are currently 5 packages of GeoSLAM Draw available. There is GeoSLAM Draw Start, Plan, BIM, Mining, and Pro. And GeoSLAM Start is practically the first step to get into Draw. You can create these autophotos as you have seen here. You're able to do the vectorizations as I've done there. You're able to do the cloud exports, but the cloud export itself is a little bit limited there because there is no RCP in there. To get the RCP export, you need to upgrade to Plan, so the second tier, where you are then in addition are able to get RCP export or import if you, for example, used another scanner and register and recap and want to bring in the data in Draw. You have more flexibility with your autophotos there. I've not shown that, but there are other autophoto tools which you then can use in Plan. You have the mergers. For example, if your CAD software is only able to import one single image and not multiple, for example, Floor Planner is like that, then you're able to merge the multiple images which we have in Draw into one merger image and then bring that into this CAD software or wherever you want to have the images. And then if you want to have everything, like you want to register a static laser point cloud, you should go with BIM or with Pro. And in Pro, you have practically every tool available. And then you can do everything with GeoSLAM Draw, which is to do there. And perhaps the last thing you want to mention, what's new in GeoSLAM Draw. So GeoSLAM Draw 4.0 is out there. If you are still using 3.5, you should definitely update to 4.0. You saw me using some tools there, for example, how I generated all the areas simultaneously from my vectorizer. This is a new feature in 4.0, as well as the distances from the vectorizer lines. Another thing we have done, as you have seen, the delta tool was generated simultaneously with the floor plan itself. So we introduced these as sheets. You're able to create multiple sheets simultaneously, so you don't need to create the same sheet over and over again, but you can directly calculate everything like color, reflectivity, shading, or the delta in one go instead of multiples. And what you've seen as well is we overhauled the complete graphical user interface, so it's a lot nicer to use and a lot more understandable what's where and what does it do. Yeah, these are the key takeaways. As I've already said, the idea of Draw is that you can combine all your point cloud data from different scanners in usage with GeoSLAM, the GeoSLAM scanners, calculate your autophotos and then directly export them to any CAD software. You see there a couple: SketchUp, ArchiCAD, AutoCAD. Vectorworks, Revit, Bentley, BricsCAD. I mean, there is in addition Allplan or ZWCAD or whatever. When we are talking about CAD software, of course, we would be interested to know which CAD software are you using. So we have a little poll for that. And yeah, since, as I said, we export everything as DWG, DXF, Collada file, you're able to bring it in everywhere.
Thank you. Thank you for letting us know your preferred CAD package as well. And just to summarize at the end, every scanner comes with a care package that covers the hardware support, the software support, and any updates associated with the system. And we started a campaign, Demo in a Box, where you can try the system in your own time at your home, where we literally send you the system in a box with everything that you need and the materials that you can follow, from unboxing the system, how to set everything up, and do your first scan. And of course, we are there to support you throughout Demo in a Box as well, to make sure that you make the most of it while the system is with you. For any case studies that were mentioned or any more case studies, please follow us on social media. Also for any news about the new products, like the new camera ZVision that will be available from next year. We are pretty much on every platform. And with this, I would like to thank you and Martin for joining this webinar, and we are going to get through your questions now. Martin, you might want
Thanks for having me, Ivona.
With you.
Yeah, perhaps let's start here. The first question, which was already asked, is how big is this 30 million point cloud file? So this is a hard question in my opinion, because if we are talking about data size, it's quite difficult to determine that, because depending on the file format, the data size can be completely different. For example, an LRS file is not compressed, so you get like all the data as same as XYZ or E57, while if you have an LRZ file, the file size is compressed and it's like 10% of the LRS file. GeoSLAM Draw is using compressed datasets as well. So the point cloud, Draw point cloud files are around the same data size as LRZ files, which are normally a lot smaller than non-compressed files, as I said.
The raw data, as it came from the data logger, was around 0.3 gigabytes.
I hope that answers that question. And yeah, of course, if you then have the images, I mean, they are only in megabytes and not gigabytes anymore, like 10, 20, whatever. All right, next one. Can you fuse more than one SLAM scan session using spheres inside GeoSLAM Draw? Yes, you can. I mean, all you need to do if you are using spheres is detect the spheres and then use the transformation calculator to transform your project into a local or global coordinate system, whatever. And if all your projects are in the same coordinate system, all you need to do is import the LSTX file, which can be found in the point cloud folder. I normally recommend to create a new project doing that and then bring all the other projects in one after another. But this is this is totally doable. There is no reason why you shouldn't be able to do that.
I can take the next one concerning panoramic images. Can we integrate new ZVision camera for Horizon? Absolutely. The vision camera can be retrofitted to any Horizon system, and in fact, it's going to be available for ZEB Horizons only from the beginning of next year, and that's going to have an option to see the panoramic images, measure from them, and colorize the data as well.
All right, then let's go to the next question. I think this is again for me. Which draw package is Martin? That's me. Using in the demo, I see there are a few different options. So I used everything through the packages itself. I mean, the video Ivona was showing was using the BIM package, but I was using everything in there from. If I check it, I don't know the packages out. In and out myself. So I was using the BIM package myself, I would say. Yeah, definitely. I mean, I didn't show the registration, but this is in BIM as well. The profiler is not in there. And I use the mesh, which is in Pro. So everything except the mesh, which I was showing, is in BIM. All right.
It comes with every hardware as well, and all the workflows are available within Connect free of charge for every system. And maybe the last one as well, whether we can correct the less accurate points or decimate less favorable data points for measurements. I think a filtering tool here would be quite useful, especially for ZEP Horizon data, where you can really thin the walls, floors and ceilings, and have nice and clean data sets to work with, where the noise would be really reduced from once the filtering tool is sticked in Connect for data processing.
Perhaps I can say something to draw here as well, but would be perhaps easier to share my screen doing that. So just a second. Yes. Okay. Yeah. So what you see in Draw, let's take, for example, this one here and get rid of all that stuff here. I mean, what you see here is, white is there are no points, and the darker we shade the pixels, the more points are above each other. So, I mean, we have a wall, there are a lot of points above each other. While when we are here, we have the floor and the ceiling, but there are not a lot of points because we are looking from above, a lot of points above each other. So if we are now looking at the wall directly, you see that the wall here is very grayish, blackish, while there is gray values left and right of there. And from there, we can deduce that most points are falling here directly into this line. And what we know about a scanner is that the scanner is producing noise. So we know that most points, or that the points are, let's say, falling here everywhere. But most points are normally directly on this line here. So the most. The others are noise. And therefore, we can measure a lot more accurate in Draw than in the point cloud itself. Because if we pick a point, if it's not cleaned in the point cloud, it might be this point, it might be a point which is directly where we want to have it, or it might be at the end. But in Draw, you're able to detect where are most points falling on flat surfaces. So you know, okay, perhaps I should pick this point instead of this in the front, if you get my drift here.
I think we can end with the questions here. So thank you again, everyone, for joining. Thanks, Martin, as well.
Thanks for having me again.
Also share the recording. So have a great rest of the day. Thank you, everyone.
Bye.